I think, as most of you know, our office is dedicated to separating sense from nonsense, and we try to shed some light into the dark world of pseudoscience. Well, this week, we're going to tackle a different kind of topic. We're going to take a look at plastics and the role that they play in our life and some of the problems that are associated with them. Where do we start? I think most of you are familiar with the classic movie, The Graduate. I know because I know the age group that we're addressing here. And I can also tell you that when I talk in class to students who, of course, are in the 18 to 21 age group, and I mentioned The Graduate, mostly you see blank faces. They just don't look at old movies, even though this was an absolute classic. And you may remember The Graduate is the story of a young man, Benjamin, who just graduates from university and is looking forward to see what kind of career he could forge. But in the process, he gets kind of waylaid with attention being paid to Mrs. Robinson. In any case, at the graduation party, he is cornered by a family friend who draws him in and whispers into his ear about, what would be successful in the future. And of course, he whispers plastics. Well, young Benjamin, I don't know if he ever got into plastics, probably not. He was more interested in getting into Mrs. Robinson. But at the time, plastics were a big deal, as of course they still are today. But this was, early on in the plastic industry when people were not used to these materials. But pretty soon, they saw them all over. There were the Tupperware parties. There was the hula hoop, and you probably remember the hula hoop craze. And we were playing with Barbie dolls and wrapping food in newfangled plastic wrap and wearing polyester fabric. It was a brand new world out there. All of these materials, which were very functional, usually very cheap. Not all of it was cheap. This was one of the most expensive plastic suits ever put together. This was the astronaut's suit that they wore to go to the moon. It had 21 different plastic layers. And of course, all the appendages here were made of plastic as well. We drove around in cars with vinyl roofs. We listened to vinyl records, and you'll still remember those. Our students today don't know what records were. And we looked at the world through newfangled plastic contact lenses. So we were looking at all of the benefits of plastics. Well, before we go any further, let's just explore a little bit here on what plastics really are. Well, they're materials that can be molded or extruded into objects, films or filaments. Usually it starts with heat treatment. You have some material, you can heat it, and you can mold it or extrude it. And then when it cools down, you have objects or fibers. Most of the plastics that we use today are composed of what we call polymers, which are just giant molecules. And the analogy that is usually given is links in a chain. And these molecules can be long or short, closely packed together or not. That will determine their properties. But besides the actual composition of the plastic, there are all kinds of chemicals that are used in the manufacture of the plastics. There are catalysts that are used that allow the small molecules to join together into long ones. There are plasticizers, which soften the plastic to make it soft and pliable. There are flame retardants to make sure it doesn't burn, antioxidants to prevent oxidation, to prevent reaction with oxygen of the air. All kinds of chemicals, as you can see, are used. And many of these, of course, are left behind in the plastic. And in some cases, cause some concern about the possibility of these leaching out of the plastic, particularly into food containers. a chemical representation of what we mean by a polymer. We start with a very simple molecule, ethylene in this case. And when you take a bunch of ethylene molecules and you line them all up and you link them together, you get polyethylene. And the properties of this, of course, are totally different from the raw material. Ethylene is a gas, polyethylene is a solid material. When we think about plastics, we used to think of them as miracle materials, all the different kinds of things that they could do for us. Today, this has changed somewhat. Today, you mentioned plastics, and people start thinking about endocrine disrupting chemicals that can leach out from the plastics. And more start thinking about the tremendous amount of garbage to which plastics contribute. And this, of course, is an issue that merits discussion, because we do have a problem with this. We do have a problem with excessive plastic, which is not properly handled, which is inappropriately discarded. And you don't have to look very far to see the mess that we are living in. You take a look at any garbage and you will see that much of it, if not most of it, is made up of plastic materials. It's everywhere. It defiles the landscape. It piles up. It is in our garbage. So let's start by looking at garbage here, just how much of this plastic ends up in our garbage. Obviously, garbage is composed of a huge variety of substances, ranging from food remnants to packaging materials to just random stuff, right? Aluminum cans, all of this. Much of this can be recycled. Unfortunately, many people don't take care to separate these, to put them into the proper bins, and stuff just gets all lumped together with garbage. Statistically, what we find in that garbage can, believe it or not, most of it is made up of paperboard, much of which should not be there because it could be in the recycling container. And then there's about 8.3% of plastic. I think that's probably less than what most people think. And again, some of that at least could be recycled, so it should not be in the general garbage. So this is basically what we're looking at when you examine the contents of a garbage bin. So what happens to that garbage? Of course, it is collected, and most people don't give much thought to this. Every Thursday, you put out your garbage bin, and it gets emptied, and it kind of magically disappears, and you don't think about it. So where does it go? Of course, first it goes into the truck, it gets compacted, and then it mostly gets delivered to landfills. It gets buried. And people are troubled by this, about the problem of burying stuff in landfill. The landfills that are made today are very scientifically designed by engineers. And these are not just holes in the ground into which the stuff is put and then covered over. These have highly engineered linings that nothing leaches through. And they have elaborate collection systems for any of the gas that is evolved when some of this garbage in the landfill begins to biodegrade, that releases methane gas. So there are pipes running through the landfill that will collect the methane gas that is evolved by the biodegradation. And this methane gas is then actually used as a source of energy. It is used as a fuel. Methane burns, and it can be used to generate electricity. So landfills can actually contribute to the electric grid, the modern landfills. So it is not true that landfills are not an appropriate way of dispose of our garbage. And certainly in Canada, we have no shortage of space for landfills. We may have to go further and further out of cities, but there is plenty of space to build landfills. Some of the garbage is burned. And this also supplies energy, because of course, when anything burns, heat is produced. That heat can be used to turn a steam turbine, generate electricity. So some is buried, some is burned. And of course, some can be and should be recycled. But this is where problems arise. Because in order to have proper recycling, we must have human involvement, obviously. And people have to make the effort to separate the stuff that can be recycled from ordinary garbage and place it in the appropriate container. Some of the garbage can be composted. Food waste, yard waste, this can be composted. However, to do this efficiently, it has to be done in a composting facility where the stuff is routinely mixed and the temperature can be controlled. The compost bins in your backyard are not very efficient, and they will not decompose most of the biodegradable material that in theory can be decomposed. So there's a big difference between having a compost bin in your backyard, which is usually inefficient, and having a very efficient industrial composting facility. So if the garbage ends up here, fine. In your backyard, it probably is not going to compost. This is what happens to the trash then. About half of it, slightly more than half, goes into a landfill. About 14% is burned, and about 31% eventually gets recycled. Of course, we have these blights on our landscape, but let's get one thing straight. These bags obviously should not be in the trees, and they are unsightly, but they do not randomly jump out of people's hands, take flight, and end up in the trees. This is because of human callousness, of not taking proper care, of disposing them properly, or, of course, best, recycling them. So people really are at fault. Where does all of this stuff come from that we find on the beaches, which is indeed very disturbing? It comes from inappropriate disposal. If these things had been put into the proper recycling bin or even into the garbage, they would not end up here. But in many places in the world, especially in Asia, there is no proper waste disposal, and stuff just gets thrown away randomly and does end up on beaches, does end up in the ocean, in a frightening kind of a way. I mean, we've been inundated recently with pictures like this of seashores just full of plastic bottles, of animals looking at these, sometimes even eating the plastic. Plastic straws, of course, have been in the news a great deal because these are single-use items. They get discarded, they end up in the water. And of course, if an animal should somehow get a straw stuck in its nose, like this poor turtle, that makes headlines around the world, as it should, because that straw should never end up in the nose of a turtle. It should never be discarded in such a way that it gets into the ocean in this fashion. And of course, nobody likes to see images like this, where this poor bird gets stuck in a plastic bag, or this duck can't get this six-pack plastic holder off of its neck. Unfortunately, a lot of this plastic is very glittery material that attracts birds. They test out to see whether or not they can eat it, and they will eat pieces of it. We know this because birds have been cut open, and indeed they are full of all kinds of plastic garbage. So we are indeed looking at an environmental problem here that has to be addressed. One of the biggest problems, if not the biggest problem in ocean pollution, are fishing nets. It's not the small plastic items that we see strewn up on beaches. I mean, those are unsightly, and of course they are a problem, but nothing compared to the netting that is out there in the ocean from fishing fleets. They get torn, then they just get tossed away. Sometimes they just lose the nets, and of course animals get enmeshed in these. And very often, of course, when they get all tied up like that, they can no longer swim and live properly. So this is indeed a huge problem. We've all heard of the so-called giant garbage patch in the middle of the Pacific Ocean. And indeed it exists. But don't get the idea that if you were plunked down there in this garbage patch, as it is called, that this is what you would see. No, you would not see large plastic items, because they would have been battered by the waves and exposed to ultraviolet light, and they get broken down into tiny, tiny particles, so that they would have to be collected by these large booms, but they're not visible in the water. This is what we call microplastic. And therein lies another problem, because these microplastics can be ingested by fish, and of course, humans can end up eating those fish and therefore have plastic contamination in their body. Now, because of all of these concerns, there have been movements to ban plastics. This is pure folly. It's absolute folly. Yes, we have environmental issues with plastics. Yes, we need to recycle much better. We need to get rid of single-use plastics. But to suggest that we should aim to eliminate plastics is just nonsense. Our world could not exist without the proper use of plastics. You are, in fact, watching me right now on plastic, because that's what your computer is mostly made up of. And no matter where we look, we see plastic. In the operating room, modern surgery could not be carried out without plastic. You look at this operating theater, almost everything that you're looking at here, from the screens to the X-ray equipment to the cover on the operating table to all of the tubing, the IV bags, all of these are plastic. It would be impossible to run a hospital without them. The syringes, the catheters, the intravenous lines, all of these are made out of plastic. The masks that we wear are made of polypropylene. They're actually made of 3 layers of polypropylene. These are made of plastic. And of course, here we have another issue, that you see these now thrown away on the street everywhere. That, of course, should not be. Right now, there's no real facility that recycles these, but I think because of the large number of these that are used, there will be technologies available for recycling them. If you fly on airplanes, that is, if we will ever fly on airplanes again, that airplane would not exist without plastics. Plastics are very light and very strong. And when you're talking about flight, that is the criterion. You have to have the least weight so that you can maximize your fuel efficiency. When you drive your car, just take a look. That dashboard is made of plastic. Your steering wheel is made of plastic. Your seats are made of plastic. The insulation around the windows is made of plastic. A car is mostly made of plastic, aside from the engine, but even that has plastic parts. We wrap our food in plastic. Now you might say, this is frivolous. Why not just have it open in bins? Well, it turns out that there's a lot more food wastage when it's in the open bins than when food is wrapped in plastic. It keeps better. It keeps people from touching the pieces that they're not going to buy. Blueberries, you think that you could have your morning blueberries, which I've always suggested people should have, if it weren't for plastic containers. How would they be shipped at this time of the year from somewhere in South America? You need to have some sort of container that is rigid enough so that the fruit doesn't get bruised. Plastic, of course, is ideal. Oh, yes, you can argue that there are containers that are made of cardboard, but when you examine the manufacturing process, you find that the making of this cardboard is actually a more environmentally unfriendly business than the making of the plastic container. So using these containers makes for a cheaper, longer lasting, and better food supply. But where we really do run into problems is with the single-use plastics. These are the plastics that are just immediately thrown away after use, the single cups. the straws, of course, which have been much discussed, the plastic cutlery at your picnic, which just gets thrown away. These are single-use plastics. But the one that is the worst, but doesn't get talked about as much, are not the straws, are not the plastic forks. These are bad enough, but this is not the big problem. This is the big problem. These are the single-use plastic containers that we really have to emphasize on exercising some control over, especially because they can be recycled. These are eminently recyclable. The plastic water bottles, the soft drink bottles, they should never end up in the garbage. It is in fact quite easy to recycle this, and it is both economically and scientifically sound to do this. So when we're talking about getting rid of single-use plastic containers, these also have to come into the picture. Fortunately, a lot of the time, these just get thrown into the garbage. Well, let's ask the question of where plastic comes from in the first place. Pretty easy to answer. Almost all of it comes from oil. Oil is a great natural resource. Of course, we don't only use it for energy. The raw material, oil is a raw material for the manufacture of numerous substances. Of course, oil is a very, very complex mix of a large number of compounds. So in order for it to be used, to be converted into usable materials, the petroleum has to be cracked. What cracking means is that the very large molecules that are found in petroleum are converted into smaller molecules that are easier to process and which can be converted into polymers or plastics. It's not only from oil wells that we get oil, we can also get the similar raw material from fracking. Fracking is a process whereby water mixed with sand is pushed down into shale deposits in the ground. And there's a lot of natural gas under the ground, but it's all locked up in small pockets inside of rocks and inside of shale. This has to be liberated. So in a fracking process, what they do is they send pressurized water, which has sand in it. Sand can be an abrasive that can open up tunnels in the shale to release the gas. The gas comes to the surface. There are problems associated with fracking. I mean, there are problems associated with any kind of oil rig. And that is because you can have accidents, you can have some of the gas leaking out. Obviously, engineers are on top of this and are trying to minimize the problems. So in any case, oil and natural gas that comes from fracking are the raw materials that are used to make plastics. And one of the simplest of these is ethane. Fracking, for example, gives us a number of very simple gases, one of which is ethane, a very simple compound, as you can see, 2 carbons and 6 hydrogens. It is possible to convert ethane into ethylene. This is a heat process. You're just cooking it up with steam, and that dehydrogenates it, meaning it takes away 2 of the hydrogens. It forms a double bond, which is a requirement because that is the double bond that allows these molecules to be laced together into a polymer. And notice also that in this process, hydrogen gas is produced, which of course is also a usable commodity, and it's becoming increasingly in demand because hydrogen is an extremely good source of energy when it is burned. So once you have the ethylene from cracking, either from fracking or from oil wells, the ethylene can be polymerized. This is not a very difficult process. The chemistry of this is well known. There are all kinds of catalysts that will accomplish this. And the ethylene can be polymerized either into straight chains or into large branch chain molecules. Well, when the chains are straight, as you see here, a straight polyethylene chain, these molecules can be packed together very closely. And this will affect the physical properties of the plastic. The plastic that we're looking at here is called high-density polyethylene, and this is the number 2 recycle logo, which of course you will see on the bottom of containers. This is very useful to make hard plastics. Many of the bottles of cleaning agents, shampoos, packaging material, insulating material, Tyvek that you'll see in houses, this is all high-density polyethylene. However, it is also possible to allow the polymerization to take place in such a way that the carbons are not joined together on a straight chain, but they also have branches. And as you can imagine, these branched chain molecules do not pack together as easily. There will be a lot of space in between them. So this is low density polyethylene, and it is used in a different way. It's not used to make the hard plastics, it is used to make various kinds of plastic film. The wrapping material that we use for food, the six-pack containers that we see, around beer containers, the plastic that you see on greenhouses, the plastic bags that we carry. These are all made of low-density polyethylene. Then we have polyethylene terephthalate, which is a very widely used plastic. It is the one that is used to make mostly the soft drink containers, and also mustard bottles, spice bottles, etc. These are polyethylene terephthalate. It's a similar molecule to polyethylene, but it has different properties because the initial material from which it is made, the monomer, is slightly different from ethylene. And this is the one that will be labeled number 1 as in recycling logos. Number 3 on the recycling logo is polyvinyl chloride, or PVC. Another very useful plastic. As the name suggests, the raw material here would be vinyl chloride. It's small molecules of vinyl chloride that are linked together to make polyvinyl chloride. This is used to make water pipes and also the so-called rubber duckies. And I'm sure, as I mentioned to you before, it always upsets me when I see these being called rubber duckies, because they're not rubber duckies, they're polyvinyl chloride, or PVC duckies. And I like them, and I do collect them. One thing about polyvinyl chloride, while it is an extremely useful plastic, it cannot be recycled. The technology is just not available to recycle this. It cannot be melted down or chopped up and made into new materials. So this eventually does end up in landfill. It cannot be burned either, because if you would burn polyvinyl chloride, it releases a chemical called dioxin. It actually forms from polyvinyl chloride when it is exposed to heat. And dioxin is a highly toxic substance. This is not something that we want in the environment. So it is always a risk-benefit analysis. The benefits of polyvinyl chloride are innumerable. So many different items can be made of PVC. On the other hand, right now there's no technology to recycle this material, but of course, constant research on trying to solve that problem. Plastic number 5 is polypropylene. This is quite similar to polyethylene, and many food containers are made out of this. And then we have also the microwave containers. This will always be labeled as microwavable. Do not use in your microwave oven containers that are not meant to be microwaved, because those can leach chemicals into the food. But if something is labeled as microwavable, then it is safe to use. Polypropylene is very commonly used, but there are other plastics as well. The polyester that I mentioned to you before, the number 1, the polyethylene terephthalate, usually abbreviated as PETE, that is sometimes used to make these microwavable containers as well. And polypropylene can be eminently recycled, just like polyethylene and polyethylene terephthalate. So these should never be thrown away. Number 6 is polystyrene. And it's interesting that the yogurt containers that you're looking at here, as well as the foamed coffee cups, are made of exactly the same material. And they are. They're both polystyrene. The difference is that when you are making the foamed container, you blow small air bubbles into the plastic to expand it. But the basic material is still polystyrene. Polystyrene is recyclable, but it is usually not financially an attractive proposition, especially when it comes to the foamed polystyrene, because it's difficult to transport. The volume of this is very large. So if you fill a truck with foamed polystyrene, you're not getting much polystyrene relative to the amount of gasoline the truck is going to use to drive it to wherever it has to be driven. There are some ways to recycle polystyrene. There is actually a Canadian company called POLYPROPYLENE, which has a process whereby the polystyrene is dissolved in a solvent so that you can compact it essentially once it dissolves in the solvent and transport it like that. And they have these containers that they are planning to distribute, into which the container, the foamed container, can be put. Inside is a solvent, cymene. It dissolves the polystyrene very readily, and then it can be transported to a facility where the solvent is evaporated, collected, and it can be reused, and the polystyrene is left behind. And this is certainly viable. The question is whether or not it's going to be economically viable, and whether or not people are going to make use of it. If the plastic doesn't fit into any of the foregoing categories, then it belongs into number 7 category. And the one that is, I guess, the most famous in this category is polycarbonate. Again, a very, very useful plastic. This is the stuff that hockey helmets, football helmets are made of. These large carboys for transporting water. Many glasses, safety glasses, are made of polycarbonate. Headlights on cars are made of polycarbonate. It is a very useful material. It is recyclable. The concern that has been raised about polycarbonate is that the raw material from which it's made is called bisphenol A. And although there's no bisphenol A, once the polycarbonate is formed, that is when the bisphenol A molecules have joined together, there's the concern that there may be remnants of the monomer that can leach into food or into water, and bisphenol A is an endocrine disruptor. However, the amount that leaches out is indeed very, very small. So let's review. You have 7 numbers that you can find on the bottom of your plastic. If it is any of these numbers, it means that it is, at least in theory, recyclable, and therefore should go into the recycling bin unless you have been advised otherwise. For example, in some places, they will not collect polystyrene because they don't have the ability to recycle it. There's something else that needs to be noted about these numbers. They have absolutely nothing to do with toxicity. There's no such thing as, number 7 being a bigger problem than number 1 in toxicity or recycling or anything. These are just identifier numbers to identify the plastic. Nothing at all to do with any kind of safety, whether it's health or environmental. Unfortunately, you don't always have the recycling logo on your plastic. So the question has to be asked, what do you do with the unmarked containers? Unfortunately, these have to go into the garbage, because if they are not labeled, then they cannot be recycled. different plastics require different recycling technologies. So they have to be properly separated. When you put the plastic into the recycling bin, everything that goes in there has to be recyclable. Don't put things in there that are known not to be recyclable, like the ones that don't have a recycling logo on there. And of course, you don't put anything that still has food in it into the recycling container. Well, once the recycling is picked up, it is transported to a facility where the different kinds of plastics are separated. And this is a very significant problem because, as I said, the different plastics require different technologies. Believe it or not, much of this separating is done by hand. People stand there for 8 hours a day as this assembly belt runs by, picking out mostly the stuff that should not be in there and trying to separate the different kinds of plastics. Now, today, there are some technologies that have been devised that separate plastic based on some sort of flotation idea, because some plastics are lighter than others, and therefore some will float, others will sink, and there are ways that separate it. But separation is the bane of the recycling industry. And it turns out that if you don't sort properly, you can contaminate a batch very easily. As you can see from the numbers here, one polyvinyl chloride bottle can ruin a batch of polyethylene terephthalate. So one has to absolutely separate before recycling or before melting down in order to recycle into something else. The worst crime is to throw away these water bottles or soft drink bottles into the garbage, because once they get into the garbage, that will most likely go to a landfill or to some sort of burning facility. And here we are burning away money, essentially, because all of this can be reused and can be recycled. The most recyclable substance is the number one, the polyethylene terephthalate. And much of our consumer plastic is made of that. So these should never end up in the garbage bin. So what do we mean by recycling this? In the case of bottles, recycling does not mean that the bottle gets washed out and refilled with some liquid. You cannot do that. You can't recycle a soft drink bottle and put more soft drink in it, because you don't know where that bottle has been, whether or not someone has stored gasoline in their garage in that bottle, which could have contaminated the plastic. So what happens in the case of this recycled polyester is the first step is that the containers are ground up into very, very small pieces, and then they are melted down. And this hot melt then can be extruded to form very fine filaments or fibers, which can be woven together to make fabric. You can make very comfortable fabric from recycled water bottles. These flannel-looking jackets are very comfortable, very warm, and they are made from recycled bottles. There is a but, isn't there always? When you wash synthetic fabrics made of plastic, you will lose some of the fibers. There will be tiny bits of fiber that will come out. You'll see these in the washing machine. Where do these go? They eventually end up in our water system. And this has been studied. And when you take a sample of water, you will find all kinds of microplastics, including tiny, tiny bits of fibers, so small that with the naked eye, you can't see it. But they may be there in the air that we breathe and in the food that we consume. So plastics do end up in our body. And this can happen in many ways. We can, breathe the tiny little particles that can end up in air as the big plastic bottles get broken down into tiny little pieces. Or these shedded synthetic textiles end up in the water where sea creatures will concentrate them. The plastic bottles, should they end up in the ocean, don't stay around very long because they will be badgered by the waves. And also when light shines on it, the plastic will start to break down into tiny, tiny little particles. Now, this doesn't happen overnight. It can take several months for this to happen. But look at the consequences. If we have these microplastics in the ocean, which can come from the bottles or shopping bags or whatever, and the tiny pieces get into fish, because fish are sort of filter feeders. They take in a lot of water and they extract the foods from it. And then, of course, if we eat the fish, the plastic ends up in our body. That is not necessarily a toxicity issue, because plastics generally are inert materials. And most of the plastic that we ingest probably comes out the other end unchanged. But if the pieces are very, very small, they could end up in the bloodstream and end up in various organs, and no one really knows what the consequences of that are. Bottled water almost always contains tiny amounts of plastic because, of course, it is very often stored in plastic bottles. And then we have the plastic bottles breaking down, as I just mentioned, and ending up in the water that eventually gets put into plastic bottles. You cannot see this, of course. You'd have to have a very high-powered microscope to see any of these tiny little pieces, but they're there. 93% of bottled water has been found to contain microplastics. Some of these are large, some of these are small. Now, large, of course, still doesn't mean that they're visible. They're still measured in microns, in millions of a meter. So they are there. But again, as you know, I've said many times when we were discussing various other chemicals, just because something is there doesn't mean that it's doing harm. That's a completely different question. And we don't know that ingesting of these microplastics is doing harm. I think it's a pretty good guess, though, that they're not doing us any good. There are all kinds of other sources of these microplastics, too. Many of the tea bags that are used today are not made of paper, but they are made of fibers made of plastic. This can leach into tea. And this has been studied. Here's such a paper that looked at the microplastics that are found in a cup of tea made with such a tea bag. Again, this does not necessarily mean that there's an issue here, because chances are that all of this comes out in the fecal matter. But again, it isn't doing us any good. So what do we do? That's the big question about how we handle plastics, because as I emphasized, plastics are a part of our life. They're indispensable, mostly. Not always. I mean, obviously, there's some inappropriate use of plastics, and certainly inappropriate discarding of plastics. As far as the bottles go, water bottles, use reusable. There's absolutely no reason to keep buying bottled water. Our tap water in North America is fine. We don't need the bottled water. It just creates a lot of problems. If you want to carry water around with you, there are all kinds of bottles that you can buy. You can buy glass bottles encased in plastic so that when you drop it, they don't break. Or you can buy polycarbonate bottles, and they're perfectly fine. The amount of any chemical that leaches out of these plastics is minute, and it's not going to be harmful. Shopping bags. Of course, these have been very much maligned because we use so many of these. They are certainly recyclable. These are made of polyethylene. They can be recycled, and wherever there's a bin for collecting these, that's where they should be put. But of course, they are also eminently reusable. And you can empty them out at home. Once you've done your shopping, put them in your pocket and use it next time you go shopping. That's what I do. I mean, you can compress them into a very small ball, and you can reuse them. And of course, they're also ideal for putting out garbage. And we've seen that in areas where the use of these bags has been restricted, the purchase of plastic bags for garbage has gone up. so that you're not really saving anything. Reuse, recycle, that's what we have to take a look at. Of course, wherever these bags are no longer allowed, you have to have some other means of taking your stuff, because not everyone comes to the store with some sort of bag. And the alternative that is proposed usually is paper. This is not quite as simple as it sounds, because a paper bag actually requires more energy to manufacture than a plastic bag. It obviously occupies more space in a landfill. It should never end up in the landfill, of course. It should be put into the recycling container. And its production releases 10 times as much air pollution. So this is not necessarily a good trade. It's reuse that we have to emphasize, not use something instead, because what you're using instead may actually be worse than the original material. Now, what about the bags, the cotton bags that we are encouraged to use? There's a little but here too. Making these cotton bags is a very environmentally unfriendly business. Cotton requires a lot of fertilizer. It requires a lot of pesticides. And if you're going to use a cotton bag, you have to use it a great deal in order to make it worthwhile in terms of its environmental consequences. Of course, you can also get these reusable bags which are made of plastic, I think, which is a pretty good idea. But you also have to make sure that you wash these bags out, because suppose you're taking meat home in one of these bags and some of the meat juices spill. You don't wash it out. Next time you go and you put your produce in there, you can get contamination. But if you use the bags properly, yes, you do not need to get new bags every time that you go to the store. So again, reuse is the modus operandi here. There are some bags that are biodegradable. That means that in theory, they should decompose mostly into carbon dioxide and water. Ones that are made from cellulose or starch generally will do that. They will biodegrade given the right conditions. And underline that term, given the right conditions, because if this bag ends up in a landfill, it is not going to biodegrade, because it has to be exposed to air, to oxygen, in order to biodegrade. But in theory, I mean, this is a good thing, because if you have a biodegradable bag, it breaks down into tiny pieces. And as it breaks down, it releases carbon dioxide. And that carbon dioxide then can be used by plants for photosynthesis. And the biomass that is left behind can actually be used as fertilizer. So this is a good thing if it works. This will happen in a proper composting facility. It will not happen in a landfill. This biodegradation can be enhanced by incorporating into the plastic certain catalysts. These are the oxo-biodegradable plastic bags we're talking about, and they will be so called. And these have been treated with a metal catalyst that allows for much faster degradation. So again, this is a good thing, but it tends to be more expensive. The end result is similar to ordinary biodegradation. You end up with water, carbon dioxide, and biomass. But again, this will not happen in a landfill. We know what is sort of the end result of putting all of these plastics into the environment, whether they're biodegradable, oxo-biodegradable, compostable, or not. Those are terms that are readily used these days because they are very seductive in terms of marketing. But the fact is that unless these substances are disposed of in exactly the right fashion, they will not biodegrade. Here's such a study where they looked at materials that were in landfills, that were thrown into the ocean, and they did not biodegrade properly. They just kind of, change their appearance, as you can see. So there's a lot of what we call greenwashing in this area. The suggestion that these products will somehow, if they're biodegradable, they will just disappear from the environment. That doesn't happen. The straws that have, of course, had thousands and thousands and thousands of words written about them, generally are made of polyethylene and polypropylene. They are indeed recyclable. But the reason that they've been so much maligned, because these are the ones that get randomly thrown away, and one of them happened to end up in the nose of a turtle, and that, of course, got a lot of publicity. But we can get rid of these. We can. There are certainly alternatives. There are metal straws that you can carry around. And, of course, believe it or not, it is possible to drink out of a glass without a straw. Now, it certainly is true that in some cases, straws are needed for people who are ill, for example, of trouble drinking things, but we do not need to use the large number of straws that we're using today. There are replacements. There are the paper straws. I don't find them very satisfactory. You get this taste of paper in your mouth. So what's the answer? First of all, we should be cutting down on these soft drinks anyway. So the question should not come up of whether you should be drinking it from a glass or from a straw. You should not be drinking it, period. And when it comes to water, there's no problem drinking it from a glass. How about this disposable cutlery? There are many different kinds of plastics that can be used to make this cutlery: polyethylene, polypropylene, polystyrene, and polylactic acid. Unfortunately, it is very rare to see a recycling logo on any of this disposable cutlery, which means that it has to go into the garbage. I don't know why that is. I don't know why they can't manage to put the recycling logo onto this. Of course, they think that people are not dependable anyway to separate them. So the end result of this is that this stuff does not get recycled. There is an alternative, and this is the wooden cutlery. I mean, it tends to be somewhat more expensive, but this really is environmentally more friendly. Wooden cutlery will biodegrade, and wood, of course, is a renewable resource. You're getting it from trees, and much of this is manufactured from trees that have been felled, but which were not taken away to be processed for pulp and paper or for lumber. There's always residues of wood in the forest, and that's what they use to make this. And this is biodegradable, and energetically, it may be a little bit more energy intensive because of transportation costs involved than plastic, but it's still worthwhile in terms of the environmental consequences. Then you have cutlery, which is advertised as being compostable. And again, in theory, this is correct. This is made of something called polylactic acid. Polylactic acid is made from corn. Corn can be degraded to lactic acid. Lactic acid can be polymerized to polylactic acid. That can be made into all kinds of plastic objects, and it can be recycled. It can go into the recycling bin, and polylactic acid can be degraded, and certainly when it biodegrades, it leaves behind only carbon dioxide and water, and the carbon dioxide, of course, is used in photosynthesis to grow more corn. So this looks like it's a nice closed loop, and it is, if that polylactic acid ends up in a proper composting facility, not in your backyard. It will not decompose properly there. You can recognize this because they do tend to label it. As you can see, polylactic acid, 100% biodegradable. Yes, it is 100% biodegradable under the appropriate conditions. One of our researchers here at McGill is working on another interesting way to make a biodegradable plastic. And this is from the shells of lobsters and crabs. And of course, a lot of these sea creatures are consumed every year. So there is a lot of material here to work with. And Professor Audrey Moores has come up with a scheme to take shrimp and crab and squid and hard-shelled creatures and extract from their chitin, which is the material of which the shells are made, a substance called chitosan. And chitosan can be formulated into plastic, and it is biodegradable. Of course, the question is whether or not this will be economically viable. And that hasn't really been addressed yet, because first of all, you have to work out the technology. You have to calculate the cost of the chemicals that are used. You have to take a look to see whether or not this is environmentally friendly. Where do the processing chemicals end up? But it's certainly worthwhile pursuing this research. But emphasis right now really has to be on recycling and on eliminating the use of single-use plastics, because we can always get around this. We do not need them. It's just unfortunate that they used a plastic bag as the logo for these single-use plastics, because it's not the appropriate one. Plastic bags do not have to be single-use. They can be multiple uses. And you know, I've used the same plastic bag that I carry back and forth to the store in my pocket. I don't know even how many times. And the plastic bags that I don't need, we use for garbage, which is a perfectly fine way to use them. So we do have to do something, because we don't want to be overrun with garbage. Recycling the water bottles, soft drink bottles is obviously something to do. Eliminating single use is certainly worthwhile exploring. But we can't just blatantly eliminate all plastic, because it would make our life much more difficult. Imagine that you don't have these plastic bags in the grocery store into which to put your fruits and vegetables, and you would just have to place them piece by piece into your cart. Well, by the time that you get to your cash counter, you'd have bruises all over the place. So we do need some packaging material, but even these bags can be reused. I use them as lunch bags. Recycling, of course, only works when you properly separate it. If you put stuff into the recycling that doesn't belong there, you're undermining the whole process. So it takes a lot of willpower in order to make sure that our plastics are handled properly. And of course, we have a really growing problem with all of the electronic equipment that is getting discarded. And there are piles and piles of this. You know, computers get discarded all the time. Screens get discarded all the time. Cell phones pile up. People get new cell phones every year or every 2 years. What happens to them? Many of them get sent off to the underdeveloped world, where parts are taken out, very often child labor, ugly business. Here too, there's no need to get a new device every year. Even though, of course, advertisers will tell you that it has all kinds of new features, which most people never end up using. I mean, most people don't need all of the different features on their computer or even on their cell phone. So there we have a picture for you of this world of plastics and where we stand. And I suspect that these days, if the friend had corralled Benjamin, instead of saying plastics, he would probably say recycle, because that really is what we have to focus on. And recycling technologies are getting better and better, more and more efficient. So that's it. And remember that you can always check out our website, because we have a lot of information about all kinds of things there. And you can also sign up for our weekly newsletter, which is free, of course, and it appears every Saturday morning in your email inbox. That's it for this month, and we will do this again next month the same way, because unfortunately, this coronavirus is not ready to leave us yet. So I don't know if we have any questions or...
Actually, there is one question. It says, assuming a plastic can be recycled, is there a practical limit to how many times it can be recycled?
That's a very good question. As I discussed, most plastics can be recycled, but not infinitely, because every time that you recycle by melting it down and reformulating into a new substance, you lose a little bit of the plastic in terms of what we call depolymerization. That is, the polymer breaks down. So yes, there is a number of times that it can be recycled before it becomes unusable.
Dr. Joshua, I recently saw on TV that there's a company in the UK using seaweed to make little packages for like ketchup and mayonnaise.
Yes, this is a possibility that many companies are now looking into, to make packaging material from seaweed, because seaweed can be farmed and you can grow large amounts of it. And seaweed already has biopolymers in it, which can be manufactured into plastics. Again, it is usually an economic question whether or not it's viable to do it. It depends on how access is to the seaweed and how access is to the manufacturing plants that can convert it into plastic. But yes, this is already on the market, but it is more expensive to produce that than to use the other kind of plastic.